expanded beam connectors in data center phase 2. This is our call for participation call. And today we have the two project leaders, Tatiana sorry, Tatiana.
No worries.
From Cinco and Faye Golami from IBM. And they're going to talk about the SOW for the project and what we have been doing. Honestly, for the past year, this is a phase 2 project, so there was a phase 1 that was completed. I think we'll mention that very briefly. But you're not here to hear from me today. You're here for Tatiana and Faye, so I'm going to turn it over to them.
Thank you, Mark. Thank you. Good morning, everyone. Thank you for the opportunity to present this new project. And again, today is a call for participation. So for today, I will go through member list, then briefly discuss statement of work, our needs and status, and later on, Mark will explain how to join the project. Mark, please go to the next slide. Well, first of all, I'd like to start with motivation. As you know, fiber data centers are using large numbers of connectors. And it's important that connections in a data center to be made right in the first time, quickly, and without potentially need of skilled installers. However, I'd like to highlight that fiber optics connectors are very different from copper connectors. Copper connectors, they don't need any inspection and cleaning procedures, and unskilled installers can be involved. At the same time, fiber optics connectors are required inspection and cleaning processes. Therefore, what we're trying to achieve in ideal situation, installation of fiber optics connectors is supposed to be the same as copper connection. Therefore, but as I mentioned, currently, installation of physical contact, PC connectors, is the most successful when the connector is inspected and clean as it installed. And this usually requires very good operators, specially trained operators. But we'll learn that it's not always followed. Sometimes unclean first-made connection is made. And if connector is not cleaned properly and mated with another connector, it simply can damage another connector. Dust can be very easily transferred to another connector. And what is important, it's leading to some changes in insertion loss in the connections and potentially has impact on the link performance in overall. At the same time, we know that expanded beam connectors do not need to be cleaned before use, and this is we proved in phase 1 of the project. Unlike PC connectors, there is no risk of damaging connector in phase because simply this type of connectors have air gap. And even one connector is contaminated, dust is not going to be transferred to another connector or a lens another connector. Therefore, expanded beam connectors offers the possibility of rapid installation using unskilled labor. This is our motivation. The objective of the project is to investigate and compare the impact of contamination on the optical performance of different classes of connectors, including expanded beam, physical contact, and air gap connectors in actual data center requirements based on insertion loss and return loss measurements. So for our strategy approach, explain on this slide. First of all, we'd like to expose unmated expanded beam physical contact and air gap connectors to air circulated in a data center environment. Secondly, we'd like to visually monitor contamination of the optical interface on a physical PC connectors or expanded beam connectors. It means on a fiber end face or lens over time. And we'd like to save all these images. Then we'd like to measure the changes in insertion loss of each connector by making and demating the connectors in a data center, if practical. And finally, we'd like to perform a mating in the data center and send the mated samples potentially to a fiber optic lab to final examination. However, we'd like also, in ideally, to perform final measurements in a data center environment, because one of the concern, if you send in connectors to some lab, after the dust may potentially be shifted. And also in this project, we are targeting to perform some theoretical calculation using occluded area, which I'm going to explain to the next slide, and calculate the changes in insertion loss caused by contamination. And we'd like to compare the calculated loss to the measurement loss. Our outputs, as usually in iNEMI project, we are going to report to industry on the quantify of contamination observed in a data center environment as a function of time. We'd like to present the pros and cons of expanded beam, air gap, and physical type of connectors. And as a result of our study, we'd like to suggest method for monitoring and evaluating different connector styles in data center to IEC, International Electrotechnical Commission, and other standardization bodies. Mark, please go to the next slide. So I'd like to start with a picture example, which on my right. This picture from previous project, phase 1, it's represent the length of the connector. It means it was expanded beam connector. I think was comments from Bunli or Mark. Do we want to go and
That, if you'd like, please. Sure. Go ahead, Bunli.
Hi, Tatiana. I can see the presentation, just to know whether it's because of me.
You cannot see the presentation?
Right.
I think it's you. I'm sorry.
Okay, sorry.
It is up on the screen. I know Tatiana and Faye can see it. So
Okay.
Yes, I'm using presentation from basically Mark's computer.
Sorry.
All right, that's fine.
Sorry, you might have to like get out and get back in sometimes.
Okay, let me try that then.
Yeah.
All
Okay.
right, thank you.
No problem. Thank you, Bunli, for joining us. Thank you. On this slide, I'd like to start with the explanation, some picture on my right-hand side. Again, this is an example of contaminated connector. This picture was taken during phase 1 of the project when we contaminated connectors, not in a real data center environment, but on a purpose in a lab. Therefore, you can see like kind of yellowish area of lens and the blue areas inside, which is represent contamination. Therefore, this lens was heavily contaminated, and the area covered by dust particles we called occluded area. It means it's prohibit light to go through the lens. Therefore, on the bottom you can see two numbers. Therefore, measurement loss was 1.7 dB and calculated loss 1.17 dB. The calculation was made using occluded area, which can be calculated based on the image. We also need to know some design parameters for the lens itself, as well as distribution of the beam. In terms of single mode connectors, it will be Gaussian beam distribution. Therefore, knowing all of these parameters, we calculated loss. Therefore, as I mentioned in previous slide, one of the objectives will be not only measure the loss in a data center environment, but also calculate the loss based on real images, real parameters from the lens, and distribution of the beam, and then compare the data. On my left-hand side, you can see a brief description of status of the project. Therefore, this initiative led by IBM and Senka, and the call participation is scheduled today on May 14th with the project launch in June targeting. And below you can see contact information for Mark from iNEMI, which definitely he can help to answer all questions related to the project signing agreement and how to join the project. Next slide, Mark, please. I'd like to acknowledge to companies who is contributed to development of phase 2, because again, today is a call for participation, but the team of 11 companies and representatives from these companies put a huge, very significant work to develop initially as a project and to create statement of work. And I'd like to mention that in our team, we had very significant contribution, first from data center providers, IBM, Face here, Microsoft, multiple companies willing to provide samples of connectors, different companies. I'd like to mention 3M, Homescope, Corning, Fujikura, Senka, Sumitomo, and US Connect. And there is 2 companies who are focusing on a test and measurement equipment, and we definitely need their help too. It's FiberQA. FiberQA is a company specializing in automatic visual inspection equipment. Viavi also provides visual inspection equipment, and Viavi also specializing in special test platform for insertion loss and return loss measurement. Therefore, thank you very much for all participants who contributed to the development of phase 2. Next slide, please. Therefore, started with a project overview. This project will investigate and compare the impact of contamination on the optical performance of expanded beam, physical contact, and air gap connectors in actual data center based on insertion loss, return loss measurement, and theoretical calculations. Therefore, what is important, we are looking not only expanded beam connectors, but we compare these connectors with other technologies, such as physical contact and air gap connectors. That is number 1. Second, as I mentioned, we are going to measure insertion loss and calculate insertion loss, and we measure return loss. And of course, we are going to monitor a visual inspection and save all images, which we are going to use for decision point when to do measurements and for theoretical calculations. Next slide, Mark, please. The project purpose. We'd like to demonstrate the benefits in terms of performance and maintenance cost of expanded beam connectors in data center applications. Yes, therefore, first of all, performance that they still getting better in terms of insertion loss measurements, and we hope to significantly show impact on the maintenance cost. Therefore, how we are going to do it? First of all, investigating the impact of contamination on optical performance, insertion loss, and return loss of multi-mode and single-mode expanded beam connector from different vendors, and experimentally and theoretically in data center environments. We'd also like to learn about realistic level of contamination at multiple locations, if possible, within representative data center. Next slide, Mark, please. This slide has a flow chart of our process. Of course, it's simplified flow chart. It's based on our experiments and studies from the previous projects. Therefore, we usually started as a baseline from initial insertion loss, return loss measurements, and probably all companies who are willing to supply connectors, they provide initial insertion loss, return loss in a lab. Potentially, connectors can be remeasured initially in a data center too. Then we are going to demate connectors in the data center. Image, it means we're going to use some visual inspection tool, potentially fiber QA visual inspection system Avid, which is targeting automated visual inspection and can do inspection of multiple MT style 12 fibers connectors very quickly. And save the images, it means collect the data. Then we are planning to expose unmated connector end face in the data center environment. And image again. Therefore, one of the question when and how we are going to decide when is going to be end of the experiment, or for how long. For now, we don't know. We are targeting 1 month potentially, or we'd like to see changes on insertion loss calculated more than 1 dB, because we don't know the level of the dust in a data center environment, and we don't know how long it takes to really contaminate connectors. After that, we are going to make connectors again, measure, clean, and remeasure, and finally to perform insertion loss, return loss measurement in a data center. After that, potentially samples will be shipped back to the regional manufacturers, to the vendors, and for their again characterization, insertion loss, return loss. You can see that down or above the boxes with initial insertion loss, return loss, measure, clean, and remeasure, and final insertion loss, return loss, there is small blocks representing additional flowchart steps. In this slide, it's again simplified, therefore it has more steps, but major steps I just explained. Therefore, again, project will study the impact of contamination on different connector technology, exposing connector to ambient airflow in a selected data center, potentially in a few locations if it's possible. We are targeting single mode and multi-mode expanding beam connectors based on different technologies. Thank you, Mark. Please go into the next slide. As usually for iNEMI project, we'd like to highlight what is this project is going to be focused on, and this project is not. I started with what our focus. Therefore, to focus on a data center and installation, operation, and maintenance associated with implementation of expanded beam connectors together with their performance criteria. That is number one. Second, we'd like to make comparison of different technology, physical contact, air gap, and expanded beam connectors. Then to focus on contamination performance through comparison between this type of connectors, expanded beam, air gap, and physical contact connectors by measurement of insertion loss and return loss in a data center environment. And as I mentioned, important step of the project or goal of the project is calculation, theoretical calculation, additional loss estimation based on weighted occluded area. Therefore, we are going again to compare our data, experimental data versus theoretical data. That is our project focus. At the same time, this project is not a reliability testing. Yes, we're not targeting to provide some sort of reliability testing. We are not developing a specific standard. We are not repeating prior or existing work. And we are not biased towards specific suppliers, geography, or market segments. I hope it's clear what the project is and the project is not. Next slide, please. The project outcomes. We are planning to report to industry on the quantity of contamination observed in a data center environment as a function of time, because this data for now is unknown or unavailable. Present the pros and cons related to the impact of contamination on optical performance of different classes of connectors, expanded beam, air gap, and physical contact. We are planning to suggest methods for monitoring. It means periodical visual inspection of connector and phase and evaluating different connector styles based on insertion loss, return loss measurements in a data center to IEC committee and other standardization bodies. By the way, currently there is no any standards for this type of connectors. I'm referring to expanded beam connectors. There is no performance standard, there is no visual inspection standard, therefore more work needs to be done. And provide recommendation to IEC committee on expanded beam cleaning methods based on experimental and modeling data and technology type. And of course, a collaboration with IEC committee. Next slide, please. This slide has two parts. On the left-hand side is a schedule, and on the right-hand side is our key needs. Let me start with probably our key needs, therefore, what our project need to be really successful. First of all, this is a project focused on connectors in a data center. Therefore, we need connector samples, multiple connector type needed, and several vendors already willing to provide this kind of samples. That is very good news. Second point, which highlighted in red, because now it's our gap, we need data center test bed, and which requires access to a data center space to deploy the experiment. That is number two, and this is really critical for the project success. Third, we need personnel and equipment to conduct or monitor the testing, and several companies from the list which I mentioned at the beginning of today's talk have expressed interest in providing this. And data analysis, iNEMI team will provide data analysis if we collect the data, and this is one of our project team objectives. On my left-hand side, you can see preliminary schedule of the project is a fast turnaround project, therefore we targeting 1 year for completion. And here we have 4 quarters, but first quarters after official starting date. It's a lot of work we're planning to do in the first quarter. Specifically, design and manufacture the fixtures to mount the samples for end-ways visual inspection and insertion loss, return loss measurements. And this we already discussed some details when we developed the project at the development stage. Second, we'd like to work with the data center provider very closely, understand data center requirements, arrangements to run the experiment, specific location within data center, responsible personnel, documentation, procedures, and time required for experiment. Therefore, that is all in quarter 1. And finally, finalized detailed experimental procedure and checklist. We already have some good ideas what we're going to do, but as project started, we'd like to finalize this procedure. Then in the second quarter, we're planning to do actually physical experiment. It means install the fixtures with mounted samples in the data center. It means deployment. Provide insertion loss, return loss measurements, monitor the connector end phase contamination level, and collect the data and data review. Next, we'd like to do loss modeling and the results comparison and report generation. And after that, we are planning to socialize the project results with standardization bodies, specifically IEC, SC86B, which fiber optics, and specific groups, group 6 connectors, test and measurement, group 4, and maybe SC86C active devices too. And finally, write paper and proceed with end of project webinar. Therefore, as you can see, it's a lot of activities we are planning within 1 year. And again, coming back to key project needs, we need data center test bed and access to data center for this specific project. Next slide, please, Mark. A few more details for connectors. Therefore, based on preliminary discussion during development stage of the project, 6 suppliers willing to support the project with following typed connectors. On UPC connectors, we are targeting multi-mode connectors. With APC connectors, single mode connectors, single mode air gap connectors from supplier 4, you can see in this chart, and expanded beam connectors, several suppliers, 3 suppliers willing to provide samples, including single mode for suppliers 2 and 6, and multi-mode for suppliers 5 and 6. We are planning to use MPO style connectors with 12 fibers, both single mode, multi-mode, as I mentioned, quantity to be discussed. Of course, quantity needs to be sufficient to make some statistical analysis and some conclusions based on the project. At the same time, it's a limitation by visual inspection, equipment, fixtures, and time for insertion loss, return loss measurements. Therefore, it's a pros and cons on a number of the samples, but preliminary maybe 8-10 samples per supplier. And all contamination is a natural dust, which presented in air in data center. It means dry contamination only. Next slide, please. And key details, again, this is a fast turnaround project, which we planned to complete with 12-month schedule. And the project statement includes a section for in-kind support from all the participants. And please be sure to indicate what you will be able to provide to support the project moving forward. Next slide. And our schedule. Today we have our first section for call for participation webinar for United States, Canada, and Europe, but we have later on another session at 9 p.m. Eastern Standard Time for Asia. Initial sign up ends on June 14th, and we are planning to kick off the project on a week of June 24th. And preliminary duration, approximately 12 months, start from the end of June, and present the finding no later than June 2025. I think this is my last slide, Mark.
Yeah. You could have given it to me a couple of slides ago, even I could have walked through, but that's great.
Oh, no, I can easily, if any other slides.
It goes into how to join. I can talk.
Yeah.
I will talk through this, but I want to, first of all, I think before I get into the how to join the project, to ask if there's any questions from anybody in the audience, to use your raised hand function, or Faye, if there's anything you'd like to add, since I know you've been You've been quiet, and that's okay.
No, I know we agreed that Tatiana is going to
Yes.
walk us through this presentation. And yeah, I think we're very excited about this project. We hope, especially as Tatiana said, we're looking for a data center provider to join us to make the experiments happen. So please consider joining the project. I think it's going to be a fruitful outcome. Yeah.
Yeah, thank you. Thank you.
We
It's
do-
very interesting project, and it has a lot of impact, potentially huge benefits for data center providers in terms of lowering cost of maintenance.
Correct. So I don't see any questions from anybody, so let me walk you through how to join the project. So this is a fast turn project. We will have the SOW and the project statement posted on the actual project page, and that is this terribly long link up here, which I will copy into the chat window for you to make your life easier. They're not posted there yet. I'm still finalizing a few things. In the meantime, if you can't wait, you can email me directly, marks@inemi.org, and I can send you the SOW and the project statement. Basically, this project works in two ways. If you're an iNEMI member, you'll just need to fill out the project statement. If you're not an iNEMI member but wish to participate, you will need to fill out the project statement as well as the memorandum of understanding. So this is sort of a kind of an abbreviation of the membership agreement that you would have as a member of the project. And you would email all of these documents back to me. And just so you know, if you're not a member, the cost for the fast turnaround project is $5,000 to join. So this is just really high level. We're going to leave the call for participation starts the clock for a 4-week sign up period. And so that is why we have the June 14th date. On June 14th, we will assess who has joined. Do we have all of our gaps covered? Do we have all of the critical needs met? If we do, then we'll be able to launch the project quickly into the end of June. If not, then we will reach out to wherever the gaps are or figure out what we need to do from that point to make sure that the project can be successful. So I don't know, I will ask again for any questions, or Grace, if you have any comments as well. So Grace is our newly appointed CTO at iNEMI, if you hadn't seen that announcement. So.
Thanks, Mark, and thanks to Tatiana and Faye for and to the whole team for their work, because actually this the planning phase has been quite long because there was a lot of discussion, to be honest with you, because as Tatiana said, there hasn't been this type of testing done before. So it's actually a very interesting project in that regard, and kind of leading edge in terms of doing the technical work to help develop the standards that will support the deployment of these technologies in the future. So many thanks to the team. We had quite a large team involved in the planning phase, I think 11 organizations, as Tatiana mentioned, and they were all very active and built on the good work that was done in phase 1 of this project, including developing, some unique test methods and sharing those also with the standards development bodies. So we hope that will also continue with this project. So thank you all. And hopefully those on the line will find it of interest and consider getting involved. Thank you.
Yes, so thank you all very much. And I recognize several of the names online, as well as our 2 project leaders. I do want to make sure that everybody knows that even if you have been participating in the development of the SOW, we do still need you to fill out the project statement. So please be sure to make sure that you do that. And lastly, let me give you all of the contact information that you have. I have for Tatiana and Faye. The only thing that I didn't put on there was that it's Faye's birthday today. So she's here talking with us today on her birthday. So happy birthday, Faye.
Happy birthday,
Happy birthday.
And Grace.
Oh no, I was just trying to find the birthday cake emoji.
Oh no,
Okay.
I'm sure it's in there. It's in there somewhere. I know.
Oh,
I
I'm
know,
sure. I'm sure Microsoft had put it in.
I'm sure it's in there somewhere.
Congratulations, Faye.
Thank you. Thank you, Chris.
But if you do have any questions, you can certainly reach out to me. I put my email in the chat, also the link to the project page, and Tatiana's and Faye's emails are up on the screen. And if you just can't get enough of us, you can hear this again this evening with Tatiana. Faye's gonna like do something fun for her birthday, so it'll be me and Tatiana running the show tonight. But if there's no questions, I will let folks go, and appreciate your time and attention today. And I hope that all of you will consider joining the project. And please feel free to reach out to me with any questions you've got. Thanks, everybody.
Thank you, Mark.
Thank you,
Thank
Faye.
you.
Thank you,
Thank you
Tatiana.
all.
Thank you, Mark.
Take care,
Thank you,
everybody.
everyone. Thank you.
Bye. Take care.
Thank you.
Bye-bye.
Bye.